Hi folks, before we jump in to today's lesson, I just wanted to say you have now made it through like 2 full weeks of online schooling. That's phenomenal. Keep up the great work. Super proud of all of you. Alright, so now that we know a bit of how to factor quadratics in the form of x squared plus bx plus c, right? So we learned about that last week by making a factor tree out of c, and then adding those factors in order to get your b value, right? Well, today we're going to learn how to factor ax squared plus bx plus c, where a doesn't equal 1. All right, so just like when you're doing other factoring, you're always going to try and factor out that greatest common factor if possible. And that usually looks like trying to factor when you have a non a equals to 1, right? So in this case, we have 5x squared, so a is 5. So we have 5x squared plus 15x plus 10, right? So the first thing that we'd want to do is factor out the greatest common factor, which is typically, in this case, if you're able to do this, this is almost always, your greatest common factor is almost always that first, that leading coefficient, that first number. So in this case, we see we have 5, 15, and 10. All three of those numbers are divisible by 5. So we're going to go ahead and factor out that 5 from everything. So when we do that, remember that just means that we're dividing everything by 5, right? So then we're left with x squared plus 3x plus 2. And then from there, you'd factor using the factoring of c, right? In this case would be 2. Right, so that's one option, is to try and factor out greatest common factor if possible. That's the easy way, though. All right, that's why I'm not even finishing this example, is because this is the easy way. If you were to try and do this a different way, I do finish this example in the written notes, but if we had something where where we couldn't factor out a greatest common factor, right? So if we have something like 4x squared plus 13x plus 3. So 13 and 3 aren't divisible by 4, so we can't factor out a greatest common factor. What we can do, though, is it's called the AC method. And that's because you're writing out the factors of both A and C. All right, so my factors of C are pretty easy. C is just 3, since and that's a prime number, so the only two factors of 3 are 1 and 3. All right, but our A value, we have 1 and 4, 2 and 2, and we also have 4 and 1. And in this case, we're going to want to include that 4 and 1 because the order of these matter, right? And so the reason why we have to write out the factors of A as well as the factors of C is because normally we'd have x plus a factor times x plus a factor, right? And the reason why we'd have that is because then we have x squared plus blah, 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 right? In this case, though, our first term is not an x squared, it's a 4x squared. So we either need 4x times x, right? Or we need x times 4x, or 2x plus a factor times 2x plus a factor, right? So listing out this stuff in purple, these 3 factors here of 4, those are listed because those are 3 different options for factoring. So let's go ahead and set up this problem then. I'm going to go ahead and get rid of that. All right, so when we go ahead and get rid of all of that extra stuff, then what we're left with is our 3 factors of 4 and our 1 factor of 3. So we're going to go ahead and we're going to be looking at our 3 different combinations. All right, so I'm going to split my screen into 3 different parts. All right. And I know when I do this, I have 1 times 3, 1 times 3, and 1 times 3. All right. So I'm listing out just the factors of, listing out my factors of C. And then what I'm going to do is I'm going to line up each of my factors of A. All right, so 1 and 4, 1 and 4, 2 and 2, and then 4 and 1. All right. Now, the reason why we're going to line these up is because we have to see what two factors, when multiplied together, add up to be this 13. All right. So just like when we're looking for multiples of or factors of C that added up to be B, we're doing that exact same concept, but now instead of just the factors of C, we have to think about the factors of C and the factors of A. All right. So now that we have them all listed, we're going to go ahead and multiply all of these. Once we do our individual multiplication, then we'll add them up to see which one of these sets work the best. Which one of these sets actually works as factoring. So we have 1 times 1 gets us 1, 3 times 4 gets us 12, 1 times 2 gets us 2, 3 times 2 gets us 6, 1 times 4 gets us 4, 3 times 1 gets us 3. Then we go ahead and we add those. All right, I'm going to add them in red. All right, so we have the multiplication factors written out as well as what they equal. So we have 1 plus 12 equals 13, 2 plus 6 equals 8, and 3 plus 4 equals 7. All right, so that means that this one here is our final answer. This 1 times 1 and 3 times 4. But since we know that we're going to have something like x plus a factor times 4x plus a factor, right? The only way to get 1 to be multiplied, the only way to get 1 to be multiplied with 1 is if those factors are on the opposites of each other, meaning the 4, right? So my 4 would have to be with 1, and since my 3 has to multiply my 4, my 3 would have to multiply my 4, right? Because that's my OI, my outers and my inners in my foiling, right? So because of that, since I have to, I know that I have to have them as opposites. So what we're going to go ahead and do is we look for the diagonal pair, right? And remember that this purple color down here, that has our x, and that has our x. So we have x plus 3 times 4x plus 1. So we choose our diagonal pairs in order to have our final answer. X plus 3, I get my x. So right here I have my 1x. Right here I have my 1x. Then I have my 3 up here. That was paired with my 3 on there. Same concept with my 4, right? I have my 4x here and my 4x there. And that I pair with my 1, right? Plus 1, plus 1. So that's where our 4 factors come from, is from the diagonal pairings, all right? So we started off by listing out the factors of A and the factors of C. We listed them off by listing, since there's only one factor of C, we listed off that factor with C with each of our A combinations, multiplied, added them up to see which one was our B value, and then paired it with its diagonal. I know that that's a lot of steps. I know that this is more complicated, and I know that you're still capable of getting it done. All right? So what I'm going to do is, instead of going through more examples, I included several written examples in your written notes, and I also included some resource videos with today's lesson. All right, so make sure that you are checking out in my written notes. Check out when B is a negative number and C is a negative number, right? Because that If C is negative, then your factors here, you're going to have 1 positive and 1 negative. All right? So go ahead and read through your written notes to try and find out what happens when B is negative and C is negative. All right? So make sure you're doing that in the written notes. And then check out my resource videos if you get stuck. All right? Feel free to email me too. You can always email me as well. All right? Other than that, good luck with your assignment.